Factoring, and specifically GCF factoring, is the reverse of expanding. GCF is the specific type of factoring we'll be talking about today. So by the reverse of expanding, I mean this. Let's say you had an expression like 5 bracket 4x minus 3. That means 5 times 4x minus 3. And if you were to expand that, that means distribute. You can multiply the 5 times the 4x and also by the negative 3. That expands the term. Factoring is the opposite. It's where you start with an expression like this and you write it this way. So that involves figuring out that both of these are divisible by 5, basically, and writing that 5 outside the remaining factor. When you do this, remember, is called one term, and there are a bunch of reasons why we do that. That's important to be able to divide and simplify expressions. But part of it is being able to find the greatest common factor of the original terms that we started with. So that's what we're going to be talking about today. Before we factor, you have to know how to find the GCF. Here's how you do that. Finding the GCF is very similar to finding the GCF of two numbers. What you have to do is look at the original individual terms, in this case there are 2 of them, and figure out the largest number that you can divide both of these numbers by. In this case, that's 3. It could also be that you have variables as part of your GCF, so you'll see that in the next example and in some of the other ones. Here, for instance, 6 and 4 are both divisible by 2. But both of these terms also are divisible by x. So the GCF in this case is 2x. X is part of the GCF. Another way of looking at that is by repeated multiplication. So, for instance, these two terms are both divisible by 5. 10 is divisible by 5. Obviously, 5 is divisible by 5. That's the GCF of the coefficients. As for the variables, though, sometimes it's easier to look at it as a repeated multiplication. You don't have to do this, but 10ab cubed plus 5ab squared could be seen this way. This is 10 times a times b times b times b. That's b cubed. And 5ab squared is 5 times a times b times b. This way, it's easier to see that both terms contain at least one a. That means that a is going to be part of the GCF. And they both contain at least 2 b's. You're always looking for the limiting factor. The fact that there are 2 here and 3 here means that they can both be divisible by 2. They can't both be divisible by 3. This one doesn't have enough. It's kind of like how 5 is the GCF, even though it's the smaller of these two. Because 5 can still go into 10, but 10 can't go into 5. So these 2 b's mean that both terms are divisible by at least b squared. And that means that the greatest common factor of these two terms is 5ab squared. You can sort of do it variable by variable. Here, if I were to look at this as a repeated multiplication, first of all, sorry, all 3 of these terms are divisible by 2, not 4, because 18 isn't divisible by 4. But if I look at this as a repeated multiplication, all terms are divisible by x. The fact that this one only has one x limits the fact that all the other ones can only be divisible by a maximum of 1x. So the GCF here is 2x. Okay, so how do you factor an expression, and how does the GCF help you do that? So your factored expression should look like this. You should have the GCF multiplied by the original expression divided by the GCF. And remember that since the GCF is a monomial, and we know how to do this division, you should write out the simplified version of that division. This is going to be, it's going to leave you a divided, simplified expression inside the brackets. I'll show you how that works. So first of all, we have to find the GCF. This is an example where we already found the GCF. So when we looked at it as a repeated multiplication, we saw that the GCF of the coefficients was 5, 1a, and 2 b's. The GCF here was 5ab squared. So I would write the answer as the GCF outside the bracket times inside the bracket. And now I wouldn't actually write this in the answer. I would skip to the answer, but for this first example, I'll show you where it comes from. I would do this original divided by the GCF. And so to do that division, I have to divide this by 5ab squared, and I have to divide this by 5ab squared. This one, 10ab cubed divided by 5ab squared, when I perform that division, what I get is 10 divided by 5 is 2, a divided by a cancels out, and b cubed divided by b squared is b. And for this term over here, 5ab squared divided by 5ab squared, you're just left with 1. So this, I wouldn't normally write this step. I would skip right to here. I'd write the GCF outside, and then I'd write the brackets, and inside the brackets, I would write this individual term divided by the GCF divided by 5ab squared. That's where this came from. And then this individual term divided by the GCF, which leaves me 1. I'll show you another example. But before I do, just to let you know, it's a good idea to check these. Checking this means two things. One, it means that if you were to expand this, if you multiplied it back out, you should get the original. If I multiplied this one back out, I would get the original, so that's a check. And another thing that you should check for is to see if this, what you have left in the brackets, if that has any common factors. Here, in this case, 2b and 1 do not have any common factors. So that's a check too. That's the final answer, and it is good. So something like this, let's say, I'd start by finding the GCF. We already found the GCF of this earlier. The GCF of the coefficients is 2, and the highest power of x I can take out is 1. The GCF here is just 2x. So I would write the GCF outside the bracket, and then inside the bracket, I would take my original divided by the GCF. That means I'm going to do this divided by 2x. 12 divided by 2 is 6. X cubed divided by x is 6x squared. Then this next term divided by the GCF, 18 divided by 2 is 9. X squared divided by x is x. And this last term, 4x divided by 2x, is 2. That is the answer. Again, I checked to see if I distributed, if I expanded that, would I get back the original? Check. And also, do these have any common factors? They don't. So check. That's good. Okay, next example, one we haven't seen. To find the GCF of these, if I were to write it out as a repeated multiplication, you don't have to. But the GCF of the coefficients is 4. If I look at this, this has 2 A's, 1 A, and 2 3A's. The most I can take out is 1 A. I'm limited over here. This first one has 1 B. The second term has 2 B's. This one doesn't have any B's. That means there can't be any B's part of my GCF. And all three terms have 2 C's. That means that the GCF is 4AC squared. So I'd write my GCF outside. In my bracket, I'll have my first term divided by 4AC squared. 4 divided by 4 leaves me with 1. I don't even have to write that. A squared divided by A is A. C squared divided by C squared cancels, and the B didn't get divided at all, so it stays there. It's AB. My second term, negative 8 divided by 4 is negative 2. A and A cancel, C squared cancel. I'm left with B squared. And 24 divided by 4 is 6. A cubed over A is A squared. The C squareds cancel. As a check, if I expanded this, I would get back the original. This factor here does not have any common factors within it, so that's good. And real quick, just to show you a couple of examples, the GCF of these two, both divisible by 5a, and what's left inside is this divided by 5a, and this second term divided by 5a. Here, all three terms are divisible by 6, and this one doesn't have any x's, so actually GCF contains no x's, and what's left inside the bracket is this term divided by 6, this term divided by 6, and this term divided by 6, respectively. GCF of these two terms is 2x to the power 4. So be careful when you have something like this. If I were to expand this back, to get this second term, I have to have a 1 here. And remember also that that term comes from this second term divided by the GCF. When they divide, 2 divided by 2 is 1, x4 divided by x4 is 1. I have to actually write that 1. You'll never get a 0 in there. The GCF of these, the coefficients don't have any GCFs because this one was just 1. And they all have at least 2 x's, that's x squared. What's left inside is each term divided by the GCF. GCF here, I don't know if that was a repeat, that's very familiar. And in this one here, there is no GCF. That's called prime. It means that this one can't be factored. So hopefully that will give you enough to get started. Good luck.